Hello everyone, welcome back. So in today's session, we will be learning another important algorithm, which is generating the Fibonacci sequence. This is also one of the algorithms which we will see when we are learning a new language. Initially, we would be writing the logic in that particular language for these algorithms. So today, let us try and understand what is the logic behind generating these Fibonacci sequence. All right. So let us see the problem statement. So generate the first n terms of Fibonacci sequence where n is greater than or equal to 1. The first few terms are given here. So we all know what is a Fibonacci sequence. So usually the Fibonacci sequence are given in this way. So they will start with 0. So then is 1. And the next term will be the sum of these two terms. That is 0 plus 1 gives 1. And then 1 plus 1 gives 2. 2 plus 1. So when you add these, you will get 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. And so on. So always it is the next term. The next term is always the sum of previous two terms. So that is the logic we need to follow now. Also, in the problem statement, it was given that we have to generate n numbers and n can be greater than and equal to 1. This also we need to keep in mind. So let us take the case where n is equals to 1. So in that case, our output should be 0. And when n is equals to 2, our output should be 0, 1. When n is equal to 3 and etc., you should get 0, 1, 1, and so on. It will go. All right. So the logic what we are going to build today, how we are going to think is we will keep variables. 3 variables we are going to keep. For example, A, B, and C. Now we are going to initialize A is equals to 0 and B is equal to 1 because initially in order to start this loop, where we can add the previous two numbers, we should have the initial input that is 0 and 1. That is the reason I will initialize A value to 0 and B value to 1. Now once I complete doing that, now simply I can say that C is equals to A plus B. And this particular statement I can loop until I will reach the number of terms I want to print. Now, what is the meaning of that? So first, initially we will check whether n is equals to 1. If it is 1, simply we will print A. If n is equals to 2, we simply print A and B. But suppose if n value is greater than 2, which means if it is 3 or any other number, then we will go on adding the previous two values. So what I'm going to add initially, 0 plus 1 I will add, and that C I'm going to print. Next, I will print C. Next, how am I going to move the C? Now, this entire thing I should move over here, which means now C should come here, B should come here, A should come here, so that I can iterate this. So for that, after I print the C, I will simply say that now A will have a value of B and B will have a value of C, which is very simple as you can see now. Now, A got here A got the value of B, isn't it? Because I said I'm shifting it over this side. So A got the value of B and B got the value of C. What happens to C? C is nothing but once again A plus B. So which means I can come back over here. Okay, so that is the logic. Now, let us see the algorithm, then that will be clear to us. So this is how the algorithm looks like. So we'll take one example and iterate. All right. So let us see this algorithm. So initially we will begin with the start. Declare variables A, B, C, N, and I. Okay. Now, initialize the variables A is equal to 0, B is equals to 1, and I is equals to 3. Okay. Now, why this I is equal to 3 is what we will understand when we go further in the algorithm. This is nothing but it will keep a track of which number we are printing right now, so that we should not cross the number of terms we are supposed to print. Okay, so read a number n. So let us say that I want to print the first 6 terms. So I will say n is equals to 6. Now this is saying if n is equal to 1, print A, which means if the term was to print only 1, then we should print only the A. If Else, if n is equal to 2, here it should be print A and B. So if it is the user is asking for two terms, then we simply print 0 and 1. Otherwise, we will do the step 6. Else, go to step 6. Now, before this, also please write else print. I have missed this, print A, B, and then go to step 6. Now, why exactly? Now, this else will come in picture only when n is greater than 2, whatever the value is given, which means we have to anyways print the first two terms. We have to print 0 and 1, and then we will move on to the step 6. Right? So, how is this algorithm? Let me rewrite it once again. So it will say if n is equal to 1, print A, else if n is equal to 2, print A comma B, else. Now after else you will write print A comma B and go to step 6. All right. Now let us see what is there in step 6. Now here you have I is less than or equal to 1. So initially we had A is equal to 0, B is equals to 1, N is equals to 6, and I is equals to 3. And we have printed already our output. We have printed 0 and 1. Now I'm saying I is less than or equal to N. This is a clear indication that here we are using I as a number of terms we are going to print. Okay. So now what I'm saying, now I want to print the third sequence or third term of the sequence, hence I'm given I is equal to 3. Third one I want to print. So yes, 3 is less than or equal to 6. Hence I will go ahead and say C is equals to A plus B, which is nothing but 0 plus 1. Hence the C will get the value 1, and I will say print C. That is my third term is printed here. Next, like I told you, I am now exchanging the value of A, B, and C. So A will get the value of B, B will get the value of C, and increment I by 1. Increment I will be incremented 1 because next I want to print the fourth element. So before printing, I will check whether I is less than or equal to the given number of terms. In this case, yes, it is less than or equal to 6. Hence, I can go ahead and I will say C is equals to once again A plus B, which is nothing but 1 plus 1. From where did I get? I got it from here. Okay, so C is equal to 1 plus 1, which is nothing but 2. Now I can print the fourth term. I will again interchange the values of A and B. Now A will get the B value and B will get the C value. And then I will increment the value of 5, which means next I want to print the fifth term. So before printing, I will come and check whether this term counter, whatever I have, is it still less than or equal to the number of elements I want to print, which is true. Hence, I will go ahead and say C is equals to A plus B. A is 1 and B is equals to 2, which means C has now value 3. Now I will print my fifth term 3. All right. And then I will increment the I value to 6. Now, once again, I will come back and check whether 6 is less than or equal to 6. Yes, it is equal to 6. Hence, still it is holds true. Hence, C value will change to C is equal to A plus B, which is nothing but now the sorry, we didn't change the A value. So A value now get the B value and B will get the value of C. Now C is nothing but 2 plus 3, which is 5. Hence, I will print the sixth term. And then increment I by 1. So I will increment the I value to 7. When I go back to while, I'm checking whether 7 is less than or equal to 6. No, it is not true. Hence, I will not do this particular calculation. I will terminate from the while loop and come out of the loop. So here you can also add, since no need of print because we are already printing the output simultaneously. Hence, we have ended the algorithm. All right, so I have printed the first 6 terms of the Fibonacci sequence. Similarly, you can give n value, more number of n values like 10, 20, and you can try iterating this and you can see that this will work. And then even if you give n value as 1 or 2, it will print only the first 2 terms. If at all you're giving more, it will print those many terms. All right, I hope this algorithm is clear. Thank you for watching, students. Keep learning and kindly subscribe my channel and do share it with your friends. Thank you.